Well, welcome everyone. Fantastic. Thank you for coming. I think we've managed to fit everyone in, which is excellent. So my name's Dave Giroux. We're going to spend a few minutes talking to you, but the main part of the day really is for you to go around and meet my colleagues and meet each other. And we have various projects for display on posters and demonstrations. I'm going to give you a little bit of an overview of the research centre, but importantly also introduce you to some colleagues from around the university who work with us. So the key messages in the next few slides are really, firstly, what we do, which is the first thing on here, and secondly, what we are. So, innovative digital methods transforming research. This is actually a stronger statement of the mission that this centre has had since it was created 7-8 years ago now. Innovative technology accelerating research has been the slogan for that time. Now, mission is unchanged. We are innovating in digital scholarship in Oxford. But we are working in a landscape that's moved on, both within Oxford and nationally and globally. And we're really emphasising now the transformative potential of digital technologies and digital methods. So I'll give you some examples in a minute. There's plenty to see in the centre around this. But also we are a centre here in Oxford for bringing people together, really part of the multidisciplinary capability of the university, which is fantastic. In contrast to some other universities perhaps who do multidisciplinary activities, the amazing thing about Oxford is we're strong in all disciplines. So the combinations that we can bring together here are absolutely fantastic. And this today is an example. We don't want you just to see what we're doing, we want you to meet each other. We had a briefing for sort of friends and family of the centre a couple of weeks ago, in which I spoke for a while about giving an update on the centre, but then people from all over the university were chatting with each other about research and research collaborations. That's really what we want to really reinforce today. We are a collaborative centre. Fits part of this sort of ongoing, emerging digital Oxford strategy, which you'll hear more about as the day goes on. As a backdrop to all of this is the way we do research is changing. And in talks like this 10 years ago, we would have had a picture now of the Large Hadron Collider at CERN and talked about how many terabytes, which don't seem very big now, of data it would produce. What's different now, of course, is that we're seeing new forms of data across all disciplines. Wherever you work in the university, you may be working with new forms of data. I don't emphasise quantitatively how big data has to be. That's not the point. It's that the new forms of data may be correct in quantity, in velocity, in quality. The point is our methods have to change. And it's those changing methods that the centre is all about, because they enable the new research. Just to reinforce the importance of big data at this point in time, this is an RC UK, Research Council's UK slide on the investments across all the research councils currently in big data. As you can see, there's a lot going on there across all areas, including the spectrum from commercial and business data on the left through to research data on the right. And we cut across all of that. This includes open data, it includes securely held data. It's actually a significant investment that the Science Minister has made over the last few months. As it happens, I'll just mention this in passing, Parliament are discussing on Wednesday whether or not to do an inquiry into big data. And I've been invited to give the opening presentation to raise any concerns the government should have about big data. So if anyone has any concerns about big data, this is a good day to raise them, and I can let them know on Wednesday. It isn't only OERC, the research centre, that works with this sort of data-intensive, data-centric working, these changes in methods, but various digital stakeholders across the whole of the university, not all of which are represented on this slide, some of whom you will hear from in the next few minutes and through the afternoon. It's really fundamental, I think, to digital scholarship in Oxford that it isn't just one centre, but it is a set of different centres and institutes and departments that one way or another are supporting innovation in digital scholarship across all disciplines. Many of them are mentioned here. Later on you're going to hear from the Bodleian Libraries, from Wolfram Horseman, from Howard Noble from IT Services, from Ralph Schroder from OII, Oxford Internet Institute, and from one of our projects in particular, to give an example of work we've done, which is climateprediction.net. This picture is a big picture. It captures the space we're in. And that top right-hand side of the picture can be labelled many things, because it basically is where all the action is at the moment. So for different audiences, I have different words in there. Sometimes it says the future. Sometimes it says crowd and cloud. Sometimes it says new forms of data acquisition and analytics. But today it says social machines. And if you want to hear more about those later, I'm sure I'll come back to that in a later talk. The point is that not all computing has to be in the top right of this picture. Certain things down in the bottom left are where we have a smaller number of people working with a smaller number of computers are very important as well. But what's happened over the last few years is that there's been this ongoing e-infrastructure, high-performance computing, supercomputing investment has taken us up the vertical axis there. More computers, more storage, more processors, more cores, more devices. Moore's law. And along the bottom, we have the increasing number of people who are engaged in the digital world, not just scholars, but citizens. And those two things have tended to somehow occur separately. So sometimes we have this big investment in e-infrastructure, and people are seeking lots of users for that and perhaps not getting so many users. Equally, the people who are engaging with the digital world could do with a lot more computational capability and data capability, and don't always have access to that. So that's one of the reasons the top right-hand corner is important. And that's exactly the space we're in now. So e-science, e-research over the last 10 years in this country and globally has really shifted from the top left of this picture towards the top right, and we're firmly in the top right. But as I say, I would use this slide if I was talking about ESRC, digital social research strategy. I would use it to talk about big data strategy in other areas, because it's the really interesting and complicated space where large numbers of people come together with large amounts of data. Whether those people are helping create the data through citizen sensing, for example, whether they're helping analyze it through citizen science, whether they're working for the machine through Amazon Mechanical Turk, or whether they are online communities using computers to new ends in terms of collecting information and doing new things with it. So that's the space we're in. And up there, the way research is done has changed over the last few years. It's quite well documented. I'm not going to go through these in detail, but I just like the title of this paper by Doug Kell, who was previously the chief exec of the BBSRC. Here's the evidence, now what's the hypothesis? The complementary roles of inductive and hypothesis-driven science in the post-genomic era. The point being that where traditionally scientists may have started with a hypothesis and gathered the data through an experiment, it's now possible to start with the data and derive hypotheses, and this enables new things to be done. It's a new tool. Research results are coming out that just couldn't have happened before. Some people take that further. I don't necessarily agree with the next one, but back in 2007, the end of theory, the data deletion makes the scientific method obsolete. So that suggests that the new methods actually make obsolete the old ones. We can discuss that. Big data now in recent years has really become highly fashionable, and there's been quite a lot of emphasis on what you can do just from the data, not using some of the traditional techniques, and there's a certain amount of tension around the methodological tension around the way these things are used, and this is playing out in important academic discussion. And within the science world, definitely, Microsoft a few years ago now produced the fourth paradigm book. I have a pile of these in my office. I have 20 paradigms in my office. This is where you start with the data. I think that some disciplines would always say they started with the data, so sometimes we call it the first paradigm. The thing that distinguishes the work in this centre from a lot of other areas which are supporting data-intensive science one way or another, data-intensive research, is the emphasis on the technology early adoption. So this is classically the adoption curve, and today I'm not going to focus on the chasm, which is the usual purpose of this curve, but just to make the point that we are early adopters of the technology. We're using absolutely the leading edge hardware and software techniques, and that innovation is important. Obviously research needs to be enabled to be digital research and to help people across all disciplines, but actually innovating in the methods is the space that we're in. So our mission continues to be being on the cutting edge of digital scholarship. Our means of engagement, as a collaborative centre, is to focus on specific projects with scholars from all over Oxford, and we have many of you in the room, principal investigators on projects all over Oxford whose postdocs are in the centre. So we have about 30 postdocs in the centre. They're doing research. We're not necessarily in a support role, we can do that, but we're actually conducting the research. This is how we derive the new methods for doing things. So we refer to that as digital methods. We build that capability, and the amazing thing about this centre is that as you walk down the corridor, you'll walk past a room of astronomers and a room full of digital humanists and so on. But actually they can then talk to each other. And even though when we talk to a researcher in a particular discipline, we might want you to feel special and unique. We might think to ourselves, actually, I know how to solve that because I can use that technique from over here. And it's that cross-fertilisation that occurs within the centre that builds the value of the centre. So what we can do as we engage with people is to move from, first of all, helping with the projects, perhaps producing, answering old research questions in new ways, but then when we really help with the problem solving and defining new projects, then we move into this area where really the scholars and the digital methods people come together in a way that you can answer new research questions in new ways. And that's the transformation that we talk about. And better still, our goal is to share that. That isn't just something we do on a one-off basis, but that helps us collaborate with others, and we can share those techniques and methods with the community within Oxford and beyond. As a result of all that, we have this ongoing focus also on the process of research, the process of digital scholarship. So we reflect occasionally on how these things are done, and one of the things we're really quite aware of is that our scholarly communication system, the research communication system, is really 350 years old now. That's when the Royal Society first invented open science with the philosophical transactions of the Royal Society. And you do have to wonder with all these changes whether those scholarly methods are really still fit for purpose. And I can argue both ways on that. That's another talk. But we're really interested in that discussion. In particular, at the moment, as data is becoming a first-class citizen in scholarship and software as well, then we're very interested in how those things are cited and shared and used and reused, and discovered, and how you add value to them. So we're quite engaged with that discussion about scholarly communication as well. Now, what I could do in a talk like this would be to go through all the sort of skills and expertise of everyone in the centre, but that sort of catalogue would take a while, and you can meet everyone anyway during the afternoon, and you can talk to people at the posters. So I'm not going to go through all these different sort of technical areas of competence. What I want to do instead is just mention some thematic areas of research to give you a sort of taster for some of the things that are going on, and then you can talk to people to find out about the details of these as suits your own interests during the afternoon. So one area, for example, is life, natural and biomedical sciences. And what you can see on this slide is key areas of activity, which touch on some of the things I just mentioned in terms of data management, but also in particular their semantic web, which is something you'll find comes through in quite a few of these projects. But the important thing here, I think, is also the different communities that we work with and for. So we're engaged through the whole of the research life cycle, from the data capture through to the scholarly communication and the data curation and preservation. And you see also from this slide the partners we have. They're not just within Oxford, these are all over the country and all over the world. They include industrial partners and university partners as well. So that gives you a taster for what we could do looking at any particular area of the centre. Now I'm just going to give you some taster projects across other areas. So energy and environment, obviously hugely important and hugely multidisciplinary area of work. And just to pick out 3 projects there, you can come along to a talk later this afternoon to hear about more. Climateprediction.net, we'll hear about this one in a second, is a great example of that fourth quadrant, the top right quadrant, where the crowd come together. And this is where, crowd and cloud, if you like, this is a citizen science piece where people are using volunteer computing to help with research into climate issues. Complemented then by looking at energy efficient and energy aware computing. I think the point being there that we can use really advanced algorithmic techniques and awareness of the latest technology to help with these issues which affect the whole planet. And then associated with that, of course, showing the multidisciplinarity is the economic perspective on that. For example, looking at energy pricing and then the whole smart grid piece. So if anyone's interested in any of those things, you need to come along to the talks by David Wallum later in the afternoon, which also will include cloud computing. In the physical sciences engineering area, just pulled out some 3 or 4 projects here to make a point about different things that we do. The first one there, Artemis, is really using the very high-end GPUs, the graphical processors that are coming out that we're using in scientific computation at the moment to do new astronomical discoveries. The next one there, CRISP, is a project that augments the Square Kilometre Array project, and for us this is the creation of a test bed where we can try out things for the SKA community. That's being created in the centre. It's a really nice example of what the centre can do in terms of being on top of the new technologies, really understanding the application of those in science. The third one is a community-oriented project, A-Search, which is again trying out algorithms on GPUs and on new and emerging architectures, enabling others in the community to try out their software to help ultimately in decisions about hardware and hardware procurement. But again, a nice example of us providing a service there to the whole of the country. And SKA itself, hugely important collaboration for us with astrophysics, working very closely with astrophysics. We have a particular focus on science data processing in the square kilometre array, which is now sort of the standard slide instead of the Large Hadron Collider, when you want to talk about absolutely huge amounts of data coming very fast and trying to get them across the planet. Lots of challenges there. Arts and humanities and social sciences. And on the social science side, just to mention a couple of things, social machines, SOCIAM, is a project that's looking very much in that top right-hand quadrant again, where we're really here looking at computer systems which with people are behaving in ways that the people have prescribed rather than the developer. So Wikipedia, the way Twitter is used, Ushahidi for the political sort of intelligence in the 2007 elections. This is really good examples of systems which have actually evolved in their behaviour according to their use by citizens as much as by the developers who didn't necessarily prescribe on day one exactly how these systems would be used, but they've evolved. And it's these socially constituted systems which we're very interested in the social machines projects in combination with Southampton and with Edinburgh. We want people to think about designing social machines rather than thinking about designing computer systems, because we believe that's actually the right take on everything. That's the sort of user centricity, although we don't like the word user, that you'll find in the centre. Similarly, with all these new technologies and that picture in the top right-hand quadrant and where we go from there in terms of going further up or to the right, we have to think a lot about the ethics. Lots of challenges in there, particularly around the automation that occurs. And we don't just mean ethics as in the sense of an ethics approval process that you might need for your research traditionally within this environment, but we mean the ethics of the product and the purpose of the research as well. So it's a broader discussion. That's in conjunction with computer science. Over on the right, just to mention a European project which the technical director works for us, called Clarin, which is in the computational linguistics area. Digital humanities at Oxford. I'll say a lot more about it in this room later in the day if people want to know more. But this is not just humanities meets digital in the humanities division, but this is an area of research and a strategy that has transcended that activity and has now been taken up by other of the digital partners across Oxford. The Digital Social Research Programme we ran for 4 years from here for the ESRC. So this was social science. I think now would be called computational social science, but we call it digital social research. And the AHRC logo there is to remind me to mention a new project we just had funded from the Digital Transformation Scheme of AHRC on transforming musicology, which just captures the transformation thing brilliantly, because the opening sentence is, digital has transformed music, now it's time to transform musicology. So we're very excited to be involved in that, working with the music faculty, and we just appointed a DPhil student in that area. And Claros, again, I'll talk more about later in the afternoon, but a tremendous example of a project that's brought people together from around Oxford, led by Donna Kurtz, which has really set the scene for our multidisciplinary digital humanities work across the university. And this is bringing the world of art onto the semantic web, the data web, if you like, but it's more than an aggregation of fantastic collections in multiple museums and institutes, because it's adding a lot of value in terms of the engineering expertise and computer science techniques that have been brought in from colleagues Andrew Zisserman in engineering. So a nice example of collaboration. So I don't want to talk to you for too long. I'm going to hand over to the others. So let me just sum up by sort of unwrapping the onion skin of our ERC. So within the university context, this is our cut of projects within the centre in collaboration with other divisions. So you can see from this that although we sit administratively in MPLS, and we're very happy and very well supported by MPLS, we actually work across all divisions. The management structure of this centre involves representations from all parts of the university. So you can see we're working with medical sciences, with MPLS, with social sciences and with humanities across our overall portfolio of projects. And then we engage with other cross-university activities which are multidisciplinary and have, in some senses, similar challenges and ambitions to us. So the cybersecurity activities led from computer science, but again, very multidisciplinary. The new Centre for Doctoral Training, the new Global Capability Centre. We also engage with the Massey School, who work in an interdisciplinary way. Oxford Open Science is on there as well. This is a more informal group that meet monthly in this building and hold some excellent events and organise some much larger events, have a great stream of visitors coming through as well. And then we just expand geographically slightly. We've had for a few years this activity known as eResearch South, which started off as Oxford-led with Southampton, Reading and Rutherford. And over time we attracted new partners including King's, Brunel, Bath. That in a way is also is transcended because that's still going. But you may have heard also something called SES5, and I always forget what that stands for, but these regional groupings are becoming quite significant at university level, but certainly at an e-research level. That's been a significant activity for us. And then nationally, a few years ago there was the National E-Science Centre in Edinburgh. 2 years ago that ceased, and although there had been at least 10 centres around the country, there are only 2 or 3 left now, and sort of de facto we are really the national centre. We're the centre that is seen by the rest of the world as the UK e-research centre. Gives us a lot of connectivity nationally and internationally. So for example, the Software Sustainability Institute, joint with Edinburgh, Manchester and Southampton, has over the last few years gone a long way, not in just helping sustain software, but helping people to learn how to do that. In fact, helping people to be trained to teach other people to do that. So we're building that capability and that capacity within the community. We chair something called the EUC, the Infrastructure Academic User Community Forum, which is part of the interface between the academic user community and government, who are funding things like the e-infrastructure and big data investment. We've run, for the last couple of years, the Digital Research Conference here in St Anne's last year and St Cat's the year before, which is really, for example, this year focused on what is data science and what is the data scientist. That emphasis on the science and on the people is quite significant. I prefer those terms actually to big data, which will at some point go out of fashion, because it's absolutely the peak of the Gartner curve for the peak of inflated expectation at this point in time. So we know that we're out of fashion. We're a centre of excellence for NVIDIA with the GPU work. And then we could keep unwrapping. In Europe, we're representatives in the European E-Infrastructure Reflection Group and the European Grid Initiative, EGI. So we're very much engaged in the European e-infrastructure, e-science, e-research world as well. That's probably enough from me. For more information on any of the things you've seen there, look at our website, our wonderful new website that was launched a week ago. Thank you to my colleagues who've been involved in this. What I've just done actually is go through the green bits on the home page here, the collaborations. But if you want to know more detail about the particular research areas, then you want to click on the orange bits. And to remind you that we're a collaborative hub, really also watch out for what's going on here. And if you want to organise events, if you have visitors to the university who would love to meet others and have multidisciplinary conversations, then we're here. This is an event we'll run annually. We run many other events as well. We run the conferences. So we're very pleased to use this space to support multidisciplinary research, digital research in Oxford. So with that, I'm going to hand over to some of our partners who've been mentioned in passing in the last few slides. And the first of whom will be Wolfram Horseman from the Bodleian Library. Wolfram, I'll get your slides up for you.
Yes. So, thank you, Dave. Hello, everybody. I think I know at least half of you, which is a good sign and shows that OERC works and we work together and get to know each other. So, when we're talking about the libraries, you probably think, or many people think about this, the beautiful buildings and the beautiful books we have, but this is not what I'm going to talk about today. It's really about what do we do digitally, and this is just one slide that is representative for the many projects that we have, which is a visualization of the Republic of Letters. That means correspondence of scholars in the 17th and 18th century. And we're not only doing research projects and digital projects that are referring to historic materials, but we're also giving, for example, identifiers to research data, and that was already mentioned, that are produced today. So what we do is, and how we see ourselves is that we are the, and what we can bring to the table actually in digital research in general, is that we are the chief content provider at Oxford. I mean, OUP is sitting here as well. That's probably the biggest content producer, but for the scholars and the students at Oxford, we're actually the organization that produces, that gives most access to the materials. And we also have a lot of projects going on, so I think this can complement what is going on in the e-research center very, very well. So we have around 1 million a year, probably dozens of, currently I think a dozen of projects going on, 30 project staff, and we're working very, very closely together with the e-research center in most of the projects. What we also can bring to the table in digital research is actually the content and make it available to research. And this is something that is completely underused at the moment, and I think also underestimated. We have lots of structured data. So 15 million metadata records with, I don't know how many, 20, 30 fields in it. And if you think in terms of nodes and edges this graph would have if you would produce it, it's really, really huge. And this is completely underused at the moment. It's not used at all because libraries are used to work with structured data, and we really need more people to access this data and work with innovative methods on them. We have around 2 million objects, high-resolution images for the most part, but as mentioned before, we are starting to actually collect objects in the born digital realm. That means research data, and I think this will become a big task in the future. And while Dave was talking about social machines, we're not only producing the content, providing access to the content, but we're also having a huge user base, so 70,000 registered users. And the amount of usage data that we have there, because I mentioned here in the first line actually that we have one transaction for a digital service a second. That means a download, a catalog search, a website visit, not a hit on a website. So really user-generated transactions, one a second. And we don't use that at all at the moment, these data. Well, we use it, of course, for informing our services a little bit, but we're not making the connections that could be made there. So there's a huge content resource, that is the message here. And we're also representing, I think, a little bit the museums in general, and Dave was already mentioning the Claros project. So there is a lot of more content available that can be put on the plates of the researchers for processing. So what we're doing is to join up in the digital projects. There is the digital humanities, and later there will be a talk about it, so I won't go into detail in this area. We are, of course, working on scholarly communication. We're having the institutional repository. I look at David Schotten there, who is producing the open citation corpus. At the moment, that is certainly an area we're interested in to explore further. And as already mentioned, producing the research data. And we're also talking to people like Andy Richards. Where is he? He's over there, for how we can provide infrastructure for the university. That means computing and storage and preservation infrastructure that allows to make optimal use of the content resources that are available. The digital methods community was already mentioned. The collaboration between digital engineers is taking place every day. So I think I'm here like at least once a week for meetings. And when looking into the rooms, last week, for example, there was the Cultures of Knowledge workshop. Many people were there. I see around 10 people from the Bodleian around here today. So there is really a strong collaboration. We can make the connection between development processes that can translate services that are on the innovation edge into that can translate projects that are on the innovation edge into a service that can provide it to the researchers. And I think teaching is an area that is currently addressed in some cases, but not really systematically. We have some experience working together with IT services, for example, to produce training sessions for researchers for research data management and integrate them into doctoral training centers. But thinking about what could actually be done in terms of digital methods and building a curriculum for digital methods and integrating that systematically in doctoral training centers, that would be really an interesting alternative. Last aspect I'm mentioning is we have currently many discussions about a digital Oxford and what that could be and how that could look like in the future. So it is in the strategic plan of the university. The Pro-Vice Chancellor for Research is pulling together a group of thinkers and actors in the field of the digital. And I was just focusing here in this one, the possible collaborations between some of the central service providers, particularly the e-research center, IT services, and the Bodleian, having the three focal areas of research, content, and technology, and working together could lead to this picture I was already mentioning, that we have several innovative areas and transform them and translate them into actual services that are then provided by the Bodleian and IT services. And if you expand the lens here, you will see that there will definitely be more players, not only the three, namely also in the Internet Institute, research services, and then you have the divisions and the colleges, and trying to build something that is representing digital Oxford. So the 5 points I think in sum that I see on the joint agenda between OERC and the Bodleian are further doing digital projects together, building the digital methods team or digital methods community, translating innovation into academic services, and contributing to a digital curriculum, maybe through the doctoral training centers, and building a digital Oxford.
Thank you very much, Wolfgang. There's a nice link through to IT services to Howard. So I introduce Howard Noble from the Research Support Team of Academic and IT Group IT Services.
Thanks very much. So I'm mostly going to talk about this small team, and I'll mention some other. This is not a talk about IT services as a whole, generally. Here's our team, and I encourage you to go to this website because I'm just going to talk in quite general terms, but this website is where we're collecting the details of what we're actually doing on projects, teaching, and the advice we give. So our support can be roughly categorized into 3 main themes. One of them is research data management, and this is where we're trying to support researchers in the live phase of research data management. So here are our main responsibilities. We work, as Wolfram was just saying, with the libraries to develop a technical infrastructure that basically makes it easy to store and share data sets. We're also internally, we have external money to develop a system called ORDS, which in a nutshell you could say is a web-based, well, it's a website which allows you to either create a relational database or upload and access database. and allow many researchers across institutions to collaborate on that data set. And we also get requests to help researchers with their research data management plans, so when they're writing proposals. And we want to start next year in just generally promoting research data management. So we're going to try and look for people who are doing things well and get them to present, and then try to form a coherent picture and cross-fertilize between departments. So we're going to see what we can do there in a similar way to OERC. So many of our team have expertise in text encoding and worked a long time with OERC on digital humanities. And there we're working a lot with the humanities department and using Drupal to develop a website where the emphasis is on really trying to promote what's happening. So they're starting with a small number of groups, building a website for them, and then trying to get everybody else to come on board and try to develop a website in the same way, where they're focusing on podcasts and RSS feeds and images and trying to really bring out the research that's happening and do it as quickly as possible. Another set of requests we get a lot of is where people have a data set, text data set, and they want to clean it up and structure it in a way that allows them to do their research. So this is where we have a lot of expertise in something called the TEI. And the picture there is something that's been happening for a number of years now. It's a large summer school where people come from all around the world and who have expertise in digital humanities. And this is a picture from last year, I believe. So we do that with the OERC as well. And the third area where we give technical advice is something that we started 8 years ago called agent-based modeling, and now we kind of generally term it as in silico experimentation, because a lot of the applications people want us to help them build are not particularly agent-based modeling, not particularly agent-based, but the kind of things, so this is an example of a predator-prey model, and we're just using a tool called NetLogo, which is developed at Northwestern, and we've built a website over that so you can compose these models by assembling them a bit like Lego blocks. And so the kind of things we get asked to do is like, what is this agent-based modeling thing that we've heard about? So we do introductory courses, and we show how easy it is to build fairly simple models. And then we might get asked to help build a more complex model. And the type of models are to do with understanding epidemics. So you can have an aggregate model versus an agent-based model. And so that's a 3-hour seminar we offer to zoology second-year students. Or it might be in the business school where we build a model called the Sugarscape, which is one of the most famous agent-based models. And there it's MBA students basically having an appreciation what these kind of models are, so that if they get showed them, they would have some literacy and some skepticism about what they show. So a lot of people think models are predictive, and that's only a very small set of these kind of models. So yeah, we teach agent-based modeling, and we help research projects build the kind of models that they're interested in. So just to say that we have worked with OERC for a long time. This is the humanities, the summer school. There's a digital humanities strategy, which Dave's going to talk about later, and we contribute to that. We, as mentioned before, there's a Claros project, and this is where you're trying to bring together museum artifacts into with an infrastructure to bring them all together for one view. And here we are involved in promoting that infrastructure to get more museums involved. There's a tech service around the British National Corpus and Oxford Text Archives, so this has been going for 15 years, I think, now, or a long time at least, and we'll continue doing that. And the summer school and research data management, as Wolfram was just saying, so this is where our main responsibility is the award system. So just to say that we do all this work in as open and as transparent a way as possible, so that website brings it all together, where you can read our 3-month report. We can see the kind of projects we're doing, so we don't just give advice and teaching, we actually do internally and externally funded projects. We organise workshops and teaching we do, and we also have the Behaviour Composer, which is the tool I mentioned about modelling fraud, and other tools and open content as well. So we have a strong open agenda that we do. And we measure ourselves by the number, the spread, and the quality of support requests we get and we satisfy, and the amount of money that we bring in from recharge, which is where it's departments paying us to do work, or external money as well. We do some of that.
Great, thanks very much. So I'm going to introduce next Ralph Schroder from the Oxford Internet Institute. People often ask me what's the difference between the Internet Institute and OERC. In fact, the other day we had an event in Boston College where I was sitting next to Eric Mayer from the Internet Institute. We were taking turns to introduce ourselves. He introduced the OAI, and then I just said what he said, but change 1 St. Giles to 7 Q and social sciences to NPLS. Sometimes people say OII studies and we build. I think it's more subtle than that, because OII builds in order to study, and perhaps we study in order to build. I don't know. Discuss. Ralph.
I only have this one slide, so very straightforward, but I'll say a little bit about the OII before I start that. So we are very young. We're only about 12 years old, the OII. We do sit at 1 St. Giles, right opposite the Ashmolean there. We're young, but we're no longer the smallest social science department at Oxford. We're the second smallest, I think. So we have about 25 staff, so we've grown pretty rapidly. We've had dozens of projects in the past. We probably have a couple of dozen now. One of our aims is teaching, so we've got a DPhil program where we have about 25 students doing DPhils in social sciences. We have a master's called a master's program of social science of the internet, where there are about 25 students. So we offer a lot of training, right? I mean, digital research methods, Wolfram was mentioning this, and others were mentioning this. We have quite a bit of training for our master's and DPhil students. We also run, as part of the Doctoral Training Center in Social Sciences, we run various courses, short courses. We contribute to the methods teaching. The short courses include things like how to do research using crowdsourcing methods. We have things like using social media to do social research and so on. So that's part of the teaching that we do, and we, as I said, we have about 25 faculty at various levels, research fellows and so on, professors, who all do social science related to the internet. And some of the projects that we do, Dave mentioned the Digital Social Research Hub, and e-social science has been a major theme in UK e-research for many, many years. We had a project looking at social implications of social sciences. That's the first one I mentioned there, 2005 to 2012, collaborating very much with OERC colleagues. And more recently, Dave mentioned, the buzzword is big data. We do study that, and we also use it. So we use techniques to scrape data from the web. For example, one of my colleagues, who's not on here, who just gave one of the training workshops, does things like he looks at most popular websites on the BBC, so online BBC News. He looks at what's most popular, what's most shared, and then he kind of scrapes that and figures out what the most popular topics are. And then he sees what's actually shared in social media, Twitter, Facebook, LinkedIn, and so on. A really simple idea, but a really ingenious one. And he's, as far as I know, the first to do that. So those are the kinds of things that we do. Jumping to the second from the bottom there, we've also been carrying out the Oxford Internet Survey, which have been going now for 2003. I think they probably have the most complete picture of what people actually use the internet for in the UK. And that project is connected with the World Internet Project, so there are many, many dozens of countries who are measuring the same things in terms of how people actually use the internet, how they access information, and so on. And before I forget, actually, that last point there, the Oxford Digital Ethnography Group, I mean, that's just, again, one of the things that has emerged at the OII together with colleagues in anthropology. So regular seminars about how, for example, people use ethnography, virtual ethnography, if you want to call it that, to study online phenomena. But as I said, one of the main foci that we've had recently is big data. I'm not going to go into the ins and outs. Dave mentioned various things about big data, actually. we have long discussions about how people use big data in social science, and as I say, we also use big data in order to promote the study of various phenomena. So we have a project that Josh Cowles, who's sitting over there, is involved in accessing and using big data to advance social science knowledge, where we interview, we've interviewed so far over 100 social scientists from around the world and asked them, what do you do with big data? How do you use it? What are the issues? I think IT services mentioned that there are issues about storing data, and in social sciences, the particularly problematic issue about the privacy of data, the security of data, and so on. And yet what we're mainly trying to figure out there is which disciplines use big data for what purposes, what are the challenges, what are the opportunities, and so on. And that project, for example, deals with issues such as the end of theory, and so on, these big questions of causation versus correlation. We're just writing a paper about that, which gets you into very tricky issues in philosophy and social sciences about which came first, the chicken or the egg, the hypothesis or the testing of it, and so on. So really interesting issues there. Then we have another project demonstrating the value of the UK web domain dataset for social science research. So together with the British Library and this is a JISC-funded project, we're looking at the UK domain space. So if you have the whole of the UK domain on the web, all the links, I think 6 or so terabytes, how can you look at how that's changed over time from about 1996, which is when the web kind of started, at least in some sense started in the UK, until recently. So how can you look at changes of that, and how can humanities, social science, and other scholars make use of that to kind of trace what's been going on in the UK? So that's another project. We have yet a further project in the big data space called Data-Driven Economic Models, Challenges and Opportunities. That's part of RC UK and the digital economy, which is trying to figure out what kind of business models are there for big data uses. So are there different ways in which firms are starting to make big uses of big data, depending on whether they outsource the analysis, where they get the data from, whether they have it in-house, what kind of skills are needed. Dave mentioned earlier that this year's Digital Social Research Conference was devoted to data science. What kind of skills do data scientists need? Are the skills that we have adequate, and so on? So that's yet another project, but I've just picked these up randomly off the web, and there are plenty others on our website that are documented there. So that's it.
Thanks very much, Ralph. So we've heard from some of our partners and collaborators in Digital Oxford, if you like. I want to close with a short talk from Neil Massey from climateprediction.net to give you an example of a project so you can see what we've been doing, and then you can go off and find out about all the other projects as well. So over to Neil. I'm glad Ralph mentioned some of the collaboration between OII and OERC. Is definitely, as you'd expect, is in the web space, and we're both part of something called the Web Science Trust, and together we form a laboratory in this global network of laboratories. It's a really nice example of one of the global collaborations that we're in. Over to Neil.
Hi, I'm Neil Massey. I work at the Environmental Change Institute and also the Smith School. I'm going to talk to you about climateprediction.net, which has been a collaboration with the Oxford E-Research Centre since before even the Oxford E-Research Centre was set up. So it's been ongoing for about 10 years, and it's a collaboration with, well, Oxford Physics to start with, and now the ECI, the UK Met Office, the E-Research Centre, and also all the volunteers that we use the computing power from. So climateprediction.net is one of the longest running volunteer distributed computing projects, I think only beaten by Folding at Home and SETI at Home. It was launched in 2003 and it's been running ever since continuously. It uses the Berkeley Open Infrastructure for Network Computing volunteer distributed computing platform, which we moved to in 2004. The research focus since over the past 10 years, it's shifted slightly, but also expanded in its scope. And Weather at Home is a sub-project of CPDN which launched in 2010. So climateprediction.net is basically it runs climate models on people's home computers. So previously, climate models were once the preserve of supercomputers. You needed a large infrastructure to run them at modelling centres such as the Met Office or ECMWF here in the UK. But the increases that we've seen in processor speeds allows 10 to 15-year-old models to now run on your home computer. So climateprediction.net and Weather at Home, they use the idle processor time from these quite powerful computers nowadays to run climate models on their volunteers' home computers, and that's either Windows, Mac or Linux. We support all three platforms. And the way that we have in effect a massively parallel architecture that is limited in different ways than at a supercomputer center. So we're limited by bandwidth and storage capacity, but not by computing capacity. So we use the massive parallel architecture to run thousands of climate models in what we call an ensemble. And this, in effect, allows these sensitivity studies to be conducted in a way that would take even a supercomputing center hundreds of years to complete. So this is a quick overview of how we use volunteer distributed computing. So on the right-hand side, the right-hand side, sorry, get it right. The project scientist, he generates the experiments that he then sends to the volunteer distributed computing infrastructure. And the citizen scientist on the left, he downloads the application, which in this case is climate models. And he then runs the experiment that the project scientist has dictated on his or her own home computer. And then those results are uploaded back to the database and upload-download servers, which the project scientist can then interrogate and analyze, write some papers and publish them. So climateprediction.net itself started, as I said, 10 years ago, and it's the largest climate modelling experiment ever undertaken. That's in terms of numbers of model years that have been simulated. And the original experiment all those years ago used a coupled atmosphere-ocean climate model, which was, to begin with, had SM3 and then had CM3. And these are climate models from the UK Met Office that have been used in the IPCC annual assessment reports 3, 4 and 5. So the initial experiment was to investigate the influence on the equilibrium climate sensitivity, I'll explain what that is in a second, of sub-grid scale physics parameterizations. So the equilibrium climate sensitivity is where you double the amount of CO2 in the atmosphere. This is in a modelling experiment, although we seem to be trying to do it in the Earth's atmosphere as well. And then you wait until you reach the equilibrium temperature. So there's a time lag associated with the temperature increase due to a greenhouse gas forcing. And so you wait until this equilibrium point is reached after the time lag. So this original experiment used large ensembles of climate models, each with a different set of perturbed physics parameters to these subgrid scale physics parameterizations. And this is called a perturbed physics ensemble. And these are the results. So we've used this e-research infrastructure, and we've actually published papers using it. So a paper by David Steinfurth et al. In Nature from this original CPDN experiment, models within the perturbed physics ensemble that are equally plausible, and this means in a physical manner, so that there's various variables that you look at in the atmosphere, and if they're what we call physically plausible, that they're within a certain range, you say the model is also plausible. And these can have the equilibrium climate sensitivity ranging from 2 to 11 degrees C. And the IPCC assessment report at the time, which was AR3, actually put this figure at 1.5 to 4.5 degrees. So by using this very large ensemble of perturbed physics parameterizations, we managed to explore the uncertainty around these perturbed physics parameters and say that the equilibrium climate sensitivity had a much larger range than it said in the IPCC report. These values of 2 to 11 degrees were not equally likely, and the kind of probability and likelihood of temperatures actually matched the IPCC, but they were these outliers that hadn't been considered before. This was later revised by improving the methodology of like preconditioning, which models you actually take to represent your probability distribution. Revised this to 2.2 to 6.8 degrees. And then another paper, this was in PNAS in 2009, it showed that most of the variability in this temperature range was due to the parameterization of the clouds in the model, and this is something that's known by modelers, but we were able to show it in a very more scientifically rigorous manner, that most of the uncertainty in climate models is due to the cloud parameterizations. So on to weather at home, and this is the largest regional climate modelling project ever undertaken. And this uses a regional climate model, so a model that's centred over just a small region like Europe, for example, nested inside a global climate model. And the global climate model drives the boundaries of the regional climate model. And the regional climate model will be at a much higher resolution than the global climate model. And you begin to see weather-like features in the regional climate model. So you'll see realistically represented clouds and temperature, which will have much more realistic representation, and precipitation especially. So the models are from the Met Office again, and these are used in this Massey project, which is a Met Office outreach project to developing nations, providing some regional climate modelling capability for them. So we use the same models as that project. This is an atmosphere-only model, so we have to provide the sea surface temperatures to the model, but it is of a higher resolution than the previous HADCM3 model that we used. And our research focus now is really on looking at extreme weather events and trying to attribute them to the increasing greenhouse gas forcing. So trying to determine whether the amount of greenhouse gas that we've put into the atmosphere over the past 150 or so years is actually having an effect on extreme weather events, either a positive or a negative effect. We might think it's there's more storms or fewer storms, or fewer storms but of a greater intensity. So these are all questions that we're trying to answer. And so we don't perturb the physics parameters in this, but we do perturb what's called the initial conditions. So we provide the starting condition of the model, and we alter it very slightly, and this gives you different weather patterns within the model that are all actually physically plausible and consistent with the climate scenario that you're running. So these are the regions we have, and we've got almost complete coverage of the globe by now. We just need Russia and Siberia and South America. I should say a lot of these regions are in collaboration with other people at other international collaborations with other people at other research institutes. So, for example, in America, we collaborate with Oregon State University, and they do the analysis and provide the data storage for that region. So, some results from Weather at Home. So in 2011, Pardeep Paul et al. Published a paper in Nature looking at whether the UK floods of 2000 were made more likely by greenhouse gas emissions. And to do this, this is the method we nearly always use, is two large ensembles, one of the year that we're interested in as close to observations as possible, and another one where we model, but we remove the warming that is due to the greenhouse gas emissions over the past 150 years. So the conclusion from this was that past greenhouse gas emissions are very likely, and this is 9 in 10 chance, that they increase the risk of an autumn 2000 like flood by at least 20%. So we're talking about probabilities of probabilities, which are a bit difficult to understand, but you can think that the the flood was 20%, the increase of the risk occurring was 20% more likely, and we're confident in that in 9 out of 10 cases. And in 2 out of 3 cases, we think the risk of the flood occurring was increased by at least 90%. So we also looked at the Russian heatwave of 2010, and this was an interesting one because in the literature around this event previously, there were 2 different competing trains of thought. One saying that it was mainly natural in origin, and another saying that there's an 80% probability that the occurrence was due to anthropogenic climate change. So we again had 2 large ensembles of GCMs, and one this time with the 1960s scenario, so based on the observations of the atmosphere in the 1960s, and another one in the 2000s, and we managed to actually reconcile the 2 competing scientific thoughts that the temperature value could occur within the observations, and that it could occur within the atmosphere naturally, but the probability of it actually occurring has increased. So it means that those 2 statements are not mutually exclusive. And finally, a paper I published in 2012 looked at the UK autumns and winters and whether the odds of having a warm November or a cold December in the UK has changed between 1960 and 2000. Again, 2 large ensembles, one from 1960 to 1969, one from 2000 to 2009. And conclusions of this was the warm November of 2011, which is the 2nd highest in the central England temperature. This is a long-running temperature series going back to 1740. This will occur 62 times more frequently in the 2000s than the 1960s. But the cold December that we saw in 2010, which was the 2nd coldest in the central England temperature, is only half as likely to occur in the 2000s than in the 1960s. So there's an interesting asymmetry there in that we think that we're going to get more warm Novembers, but we're only half as likely to get fewer cold Decembers. So, okay, thank you.
Great. Thanks very much, Neil. You can see why I chose that as an example. I wanted to show you some real research results, but this was firmly a 4th quadrant project, large numbers of computers, large numbers of people, literally, and new methods. So, we haven't given you a chance to ask us questions, but you can do that all afternoon, and I'm going to let you go on to explore everything else now. There we go. So, we're in the mingle and coffee stage, and then the posters, demos and talks through the afternoon. From some specific areas that have been mentioned in passing, but back in here at 2, visualization from Min Chen, David Wallum, European Federated Crowd, ARC, Advanced Research Computing, which is a collaboration between IT Services and OERC, which was previously the Oxford Supercomputer Centre, and Richards will be presenting at 2 and 3. Susanna Sensoni will be presenting bioinformatics, and I'll be talking about digital humanities at 2:40 and 3:40. So thank you all very much for coming. Go away and talk to my fantastic colleagues. I should say that after 1 year of being director here, I do feel completely privileged to be working with so many fantastic people here and around the university. It's wonderful to have you all in a room together. So talk to the posters and demos, talk to each other as well, and see you back in here for some of these talks. Thanks very much for coming.